Hello, physics students. This lecture, brief lecture, mini lecture, will be on the lab you're going to do on Monday while I'm away. And it's a lab that addresses centripetal force. And you can see in this diagram here, kind of like what the lab setup looks like. There's a big T here that consists of PVC pipe. On one end, there's a long piece of string with a weight hanging off of it. On the other end, there's a short piece of string with a weight hanging off of it. This is here to balance the other one. And this long piece of PVC here is placed on top of a pole, and there'll be string wrapped around it that's pulled, which will cause the entire apparatus to spin. And when this apparatus spins, if there's no spring here, this mass here will start moving out like that. Some might argue that's because of centrifugal force. I argue that it's because the little weight here, this weight, tends to want to fly off, and it gets pulled in by the string, so that there's actually a centripetal force pulling it in, which is the string here, and it has a tendency to want to follow the direction of the spin, so it would fly outward. In any case, when it's spinning, instead of letting it fly outward, we actually have a spring here that tries to keep it, pull it back closer in. Matter of fact, when it's just hanging here, this object will probably be more like a little ways in here with the string, more like that, and the spring shorter. And then as you start to spin it, the object will extend out, and eventually it'll be vertical. And when it's vertical, you want to have it spin that way 10 times and time it with a stopwatch. That will allow you to figure out what the velocity of it is. And you can imagine if you're finding velocity in an object spinning, our goal is to try to find the acceleration, the centripetal acceleration, which the equation is given in the lab, but it's v squared over r. That centripetal acceleration times this object's mass should equal the force that the spring exerts on this object, because F net is simply this, because these two forces are going to cancel. So the net force should be the net force of the spring, and it should be equal to the object's mass times that centripetal acceleration. And that's what you're going to be determining in the lab. So as you're spinning it, make sure it's vertical, and see if you can get these forces to agree. You'll be measuring the force of the spring independently. You'll physically take the spring after you're done with all your trials, move it out, and you'll determine how much force it takes to stretch at a given distance. That force, when the distance is the same as this distance here, the force that it takes should be equal to the force of the spring that the spring's pulling on this mass here. So hopefully this explanation will help you as you read the lab and do the lab on Monday in class. Good luck and have fun with it. Oh, and by the way, you'll be using 4 different holes in here and suspending the mass from 4 different locations. So you'll actually have 4 different pieces of data, and each one you'll repeat 5 times. Okay, good luck with the lab.